Okay, good morning, class. Right. So all of you already here, right? Or anyone still not here? Can you please check?
One more not here.
Who?
K3.
Ketika. Can someone please PM her? Okay. So before before I continue, okay, for today lesson. Okay. Actually, can you please check? Okay. Is it correct that I stop until? Wait for a moment. Okay, already done right. Until this one. Is it correct? The last time we answered until here.
Yes.
Yes, teacher. So we continue this one, okay, for the graph. Okay, in the wave there are two types of graph. Okay, so there are two types of graph. There is a displacement time graph, and also another one is a displacement distance graph. Okay, so for each graph, okay, there's a few information that you can get from the graph. Okay, so let's see for the first one. Okay, so here it said this is the let's see the video first. Okay.
Click on the Start button. The motion of an oscillating spring can be plotted on a disc.
Okay, so if you see the video, okay, so this is O is actually it at the equilibrium position, right? So it at the equilibrium position O. So and then you will drag to B. Okay, so when you drag to B, so you can see here in the graph here, so when you O to B is the amplitude. Okay, so it's the maximum displacement. So means this one if you drag from O to B. Okay, if you pull the slotted weight from O to B. So this is the graph here. Okay, and then after that when you go back to O means it back at the equilibrium position. So it means it's at here. Okay, at this point. Okay, and then it will go up to A, right? So now it will increase, okay, until it reach the maximum displacement here. Okay, we call it as the amplitude. So it reached the point A. Okay, and then it will go back at point O. Okay, means at the equilibrium position. Okay, means at here. Okay, and then it will go back down to B. So you can see the graph is going down. Okay, so means here is at the slotted weight at the point B. Okay, so it will keep oscillate until it stops. So the graph will keep moving on, okay, until the oscillation stop. Okay, so let's see. Okay, O is what? O is the equilibrium positions. Okay, and A is what? A is the amplitude. Okay, and the time here is the T here is the period. Okay, you can get the period from the two semicircle here. Okay, or from crash to crash. Okay, or from throw to throw. Okay, so you will get the period here. So there are three info that you can get here. The amplitude, okay, and then another one is the period, and another one is actually the frequency. Okay, because frequency is 1 over T. So if you already know the period here, so of course you can calculate the frequency. Just use the formula. Okay, so for the displacement, okay, so let's say this is the graph. Okay, and this one is displacement against time. Okay, so the first information that you can get is the amplitude. Okay, and then the second one is the period, okay, from here to here, okay, to semicircle, okay, period, or from the crest to crest, okay, or from the, let's say if I add one more, so from the throw to throw, okay, so all is the period. Okay, then how about the frequency? Frequency, you already know the period, so you can find the frequency. Okay, so that is for the first graph. Okay, displacement against time. Okay, so displacement against time, 3 info you can get: amplitude, period, and frequency. Okay, so now I will give you a link. Okay, I will give you a link for you to okay, this is a peer deck actually. So you have to draw the graph. Okay, wait for a moment. Ketiga already here.
Not yet.
What happened to her? Before this, did he enter the online class or only my class he didn't?
She joined the previous classes, but I think she's having some internet problems. That's why she's late.
Oh, okay. You already text her, we can.
Yeah.
Oh, okay. Right, so please join the link. So we got 15 here. Okay, so let's see who still didn't join the class. Okay. So are you already here in the... Okay, can you see the screen here that
Just the
okay, so can you try to answer that one? Anyone having a problem because only 12 response here, so like 3 more. Three more students didn't join or maybe didn't give response yet. Okay. This is not hitting curve. Okay, this is a wave. Okay, this is chapter 4. Okay, the amplitude is 5 cm and the period is 0.4. So remember, period means to semicircle or from crest to crest or throw to throw. Right? Um, your graph should have the positive one and the negative, right? Negative exit and the positive exit also must have the curve. Okay, not only at the positive part. Okay. Right. This one, the axis is should be a displacement and time. Okay, not amplitude and time. Okay, should be the axis is y-axis is displacement s over cm, and for the x-axis is t over s. T over s. Okay, so you just use symbol and unit only. Don't need to put the title there. Just use symbol and unit. Why you put the question mark here? Um, Ketiga, can you join the peer deck, the link that I give? I will send it
Okay.
again. Okay, I will send it again. So you just join it. Okay, I give you some time, okay, to draw. Because I know it's hard to draw if using a mouse, okay. But okay, you have to put the scale for the axis, right? So they say for the x-axis, okay, you have to put the scale. So I just cannot say like, okay, from here to here is 0.4. Okay, so you have to put the scale for each point. 0.4. No scale, please show us. Please put a scale, okay, on the x-axis. Okay, for this one, okay, if you set the amplitude is the period is 0.4, right? Means from crest to crest is 0.4. But let's say if I'm calculate from here, right? 0.1 here, this is the crest and this is the crest. So crest to crest supposed to be 0.4, but this one is 0.3, correct? It means you're missing something here. What about here? There's no scale here, right? Are you sure? Maybe you put the scale wrong. So what happened at the middle here? Why suddenly set face? Wow, so big. Okay. So many type of graph, okay. Some start from 0, some start from 5, okay. My advice is you better start from 0, okay, because it's easy for you to label the scale. If you start from, let's say from 5 cm, right, you start the point with 5 cm, then later you will have problem to label all the point here. Okay, means you have to find what's the in the middle here, okay, what is the point value here, okay. So for me it's better for you if you start, okay, at the 0 here at the origin, okay. Alright, so okay. Some just put label, okay, and here they try to put the scale. Okay, I give you some time. Okay, and here I already told don't put the amplitude, okay, as the axis. The y-axis is not the amplitude, is actually displacement. That's why they call displacement time graph, not amplitude time graph. Okay, so here you should change the label A to S. Okay, and this one D over, T over S. Okay, so can we discuss? Okay, so can you see my screen?
Yes, teacher.
Okay, so let's try to answer this one. Okay, ask you to draw a graph that has an amplitude A is 5 cm and T is 0.5. So what I do is you draw a graph first. Okay, and I draw a graph. Okay,
Oh, how did you draw it so easily? Yeah.
what?
Teacher draw so easily.
Because I'm using a drawing board. I'm using drawing board. You're using mouse, right? Mouse
Yeah,
is hard.
teacher. So
Okay, let's say if I draw using mouse, okay. So I think better using mouse than I'm using the board.
Maybe teacher already get used to that one smooth
Yeah, yeah.
already.
I already got how to control the mouse. Okay, so yeah, that's why I see a lot of kind of run. Sometimes all of them at the positive, right? So if you draw like that, but I understand because you're having problem using mouse. But others, you do you have any like using a tab or something, or all of you actually using mouse to draw?
Using mouse.
Oh, okay. So this one is actually you have to level S over cm. This one should be T over S. Okay, the amplitude here is 5 cm. So this is the amplitude and you should label it 5 cm. Okay, and then for period, I already told you whether you want to take from crest to crest or throw to throw, or you can start from the origin. Okay, for me, I will start from origin because this one is much easier. Okay, so I know the period should be 2 semicircle, right? So this one is 1 semicircle, this one is 2 semicircle. So 2 semicircle is equals to 1 period. So this one should be 0.4. Okay, so means in the middle here is 0.2, 0.6, 0.8. Okay, so if you put like your start from 5, right? Some of you I notice you put like this. Okay, and here you know that from here to here is 0.4. Okay, the distance is 0.4. So means here should be like you're not starting with 0. So should be like 0.1, I think. 0.1 until 0.5. Okay, so 0.1 here. No. Here is 0.1. 0.2. Wait. I should get 0.5. So 0.1, 0.2, 0.3, 0.4, 0.5 is here. Any idea how to calculate this one? This one should be, you should get 0.5, right? 0.4 from crest to crest. So here the y-axis, the x-axis, okay, axis start from 0 here. So this one is 0.4. So 0.3, 0.2, 0.1. Yes, so 0.1 here, 0.2 here, 0.3 here, 0.4 here. See, it's quite hard, right? So you just make like starting from origin. So it's much better. You already know 2 semicircle is 0.4. So the period is 0.4 like that. Okay. So any question you want to ask for this one? Are you clear?
Clear, Chair.
All right. So let's move on to the next one. Okay. All right. So just now we learned displacement against time. Okay. So the next part what we learn is displacement against distance. So what's the info that you can get from displacement against distance? So let's say if I draw a graph like this. Okay. And this is displacement. Okay. And this is distance against distance and cm. Okay. So the unit is in cm. So displacement against distance. All right. So what you can get, the first one is of course the amplitude. Okay. So you can get the amplitude. Okay. And then the second one is the wavelength. All right. Is the wavelength. So whether two semicircle or crest to crest, okay, or throw to throw, you can get 1 lambda. All right. So one again, okay. From this graph, displacement again distance, you can get two info from the graph, the amplitude, okay, the amplitude here, and another one is the wavelength, okay. So wavelength, whether you can take two semicircle, crest to crest, or throw to throw, okay. So that's the two info you can get from this graph, okay. Just now from displacement against time, so that one's period, frequency, and also the amplitude, okay. So let's try to draw a graph for the displacement against distance, okay. Okay, so try to sketch a graph. This one, the wavelength is 4. So remember, it's easy to draw, okay, if you start from the origin, okay, because you already know two semicircle is one wavelength, okay, so you don't need to find the scale, okay. It's easy for you to find the scale there. Wow, so big. Are you drawing a tsunami? Okay, because the energy, just for your knowledge, but maybe it's actually useful for you to know. The amplitude is actually referred to the energy of the wave. If you draw the amplitude higher, means the energy of the wave also higher. Okay. Before this, have you used spear deck? I think other teachers also use, right?
Physics is the
We are
first.
the first one.
Oh, really?
Yeah.
Oh. Never mind, maybe after this many teacher will use, then you will be used to use your mouse to draw. Okay. But in exam, if you draw the wave, okay, make sure the amplitude is same, okay, throughout the time. Okay, because if you put like maybe become decrease, the amplitude is decreased, so that one means resonance, right? So if you draw the graph, make sure the amplitude is same. But this one is okay lah. I understand. You're having hard time. Okay, I try to draw using yours. This is pencil using pink. Oh. Okay. So this is the amplitude. Oh, we can change the thickness. Hmm. Hmm. 5 cm. Should be this one S, okay? For y-axis is S over cm. For x is D over cm. Not x, D and S for y-axis, D for x-axis. You cannot put any like any word you like, okay? Any letter that you like, you should put real symbol because physics they have their own symbol. So you put A, if you put X is different. Okay, in wavelength, S is actually the two consecutive of loud sound for interference. Okay, so you should put the same the correct symbol for each physical quantities. Okay, just don't put any letter that you want. Yeah. S over cm. I give some time for you to draw. 2, 4, 6, 8. Okay. Some of you already finished. Hi, I'm silly. Who's this one? Actually, I can check, okay, who didn't answer. Okay, wait for a moment. Let me check. Oh, you didn't put your name, is it? So the one is not respond is iguana. Who is iguana? Okay, next time I will teach you how to put your name because I want to know. This one can be a proof of your PBD, right? Okay, so I need to know your name because if not here it's like penguin, tiger, donkey, panda.
Teacher, my animal missing.
Your animal is missing. So all of you know your own name means what your animal
I
I
think
don't know, but I can't.
the beginning I remember. But
Oh, you didn't remember.
then teacher will no idea. You cannot.
I don't know. Sometimes some name squid, some name woodpecker. Snake. Who is snake? Who is crab? Turkey. So who is iguana actually? Oh my god.
Oh, okay, I'm penguin.
Oh, you're
Teacher, can we visit Silly for a while?
Oh my god. Why they put the animal's name like pity those who got the name like donkey. Who's
Teacher,
donkey
think on the
actually?
bright side, teacher. Think on the bright side. Donkey is a very nice animal, teacher.
Thank you, Viken. Thank you.
Oh, you already know who's donkey, is it? Who's donkey?
Don't know yet.
I don't know.
Silly, teacher. Silly.
Teacher, you go.
Oh, they why you put the hi, I'm silly because she's donkey. Oh, that why I wonder why you put suddenly you put silly. Oh, okay.
Teacher, I never knew I was donkey. I thought I was some elephant or something. Like,
Actually, they should not like put donkey as an option, right? Just put other animal.
I
There's
know,
a lot.
right,
No, just
teacher?
put cat. Okay,
Yeah,
like cat. Very.
people
There's a
hurting
lot
my
of
feelings.
animal. Why you need to put people donkey? You know, yesterday there's someone you big like cow. You know, but I don't know. Like, oh my, who is cow? Oh. All right, so it's okay. Later I will teach you how to change your name. Okay, it's not. I don't want like I don't want to teach like my student like using all the animals' name. Okay, so let's see your answer. Okay, So actually, when I see your answer, most of you got it correct, right? Okay, so here the amplitude is 10 cm. Okay, so first you have to draw. Okay, draw a wave first. Okay, wait. Oh. Yeah. Okay, so I draw the wave first. Okay, so the amplitude is 10 cm here. Okay, so this is A, and the wavelength is 4. So I took two semicircles. So here is 4 cm, here is 2 cm. Okay, and the label here should be S over cm, and here should be D over cm. Okay, so are you clear? Anyone have any question? Okay, how to answer for this type of question? When teacher sharing got the answer and the name. Oh really? Oh.
No, I mean the animal name. Not the
But we don't know like who is actually like penguin already know. We can like donkey already know. Like other one like hummingbird. Okay. Okay, so never mind. We move on to the next one. Okay. So here you can try to answer this question. Oh yeah.
Teacher, I
Yes.
can't answer. Oh wait, I can. Sorry.
Oh, okay.
Teacher, what are we supposed to find? Oh, we're supposed to find the amplitude.
Yeah,
Oh,
amplitude,
okay.
period, frequency. Okay, for the wave speed, maybe I didn't teach you yet, but the formula is V is equals to F lambda. Okay, so I put the formula here for E. Okay, V is equals to F lambda. Jadi lembik. Dia setting. Setting dia. Okay, 3 cm, 0.25. Some got 0.5 for period. Some got 0.25. Zero 0.17. Okay. Okay, so let's see who didn't answer. Snake, triceratops, and also tiger. What is a triceratops?
Some dinosaur?
Oh, dinosaur?
I don't know.
Yeah, dinosaur.
Oh,
Oh
okay.
my god. Okay, I now also got dinosaur. Huh? You don't know how to put the answer? Can you type the...
Then is the answer question then.
Oh, wait.
Uh,
Cannot type. Already can type now.
I am not sure.
Wait, I try to see first. You just can just click there, right? Then you can just type.
Where do I click? Teacher,
There's
what
an
is
answer
the
here on the right side. On your right side is they put answer here, right? So you can click there. Wait,
I'm not sure.
wait. I share my screen to you as a student.
I don't think I can find it.
You cannot find it. Wait. Mm. Okay. So you can see my screen. I share with you, right? So this one, you see you have the answer here
Have.
on your right side. Yeah, so you can just click there. You can see the arrow, then you can type like A is what the answer. They say the amplitude is 3 cm. Like that.
I don't have.
You don't have on your right side.
Nope.
Are you using your laptop or your phone?
Laptop.
Laptop. If using your laptop, should have.
I don't know.
Others having a same problem. It's okay. It's okay. If you don't have, it's okay. Others, you have the same problem. You don't have the right side here that you can write your answer here. Others?
No, chair, well, okay.
Oh, maybe line something. Teacher, the wave the wave should be in cm. Yes, cm over second. Two 16, so 0.17, 0.25, 0.5, 0.5, 0.5, 0.5, cm over s 32, 4. I give you one more minute, then we discuss. Okay, how to find the amplitude. Okay, and then how to find the period and so on. Okay, wait, I see your screen first. Oh, you didn't have. Never mind. Let's see after this. If you still have a problem, you log out and log in again. Maybe you can try to log out and log in again.
I got it already.
Okay, oh, okay.
Thank you.
All right. Okay. Hmm. Hmm. Okay. So we discuss the answer here. Alright, so the amplitude. So the amplitude is actually 3 cm. Okay, so this is the amplitude. You can take Bose graph also is the same, right? So you can use either Bose graph. Okay, so the amplitude is 3 cm. Oops. Okay, so A is 3 cm. Okay, then the period. So for the period, you should take displacement against time. Alright, so don't take displacement against distance. So you must use this graph. Okay, so for period, take two semicircle that is 0.5. Okay, so 0.50 second. Okay, and then the frequency, you already know the formula. F is equals to 1 over T. So the period, we already know 1 divided by 0.5 should be 2 hertz. Okay, so the answer here, the frequency is 2 hertz. And then for the wavelength, so for the wavelength, you cannot use this graph. You have to use displacement against distance. So again, we take two semicircle. Okay, we take two semicircle here. So you can get straight away the wavelength is 60 cm. Okay, and the wave speed, okay, I give you the formula there. V is equals to F lambda. Okay, so V is equals to F lambda. So the F already calculate 2 and the lambda actually the wavelength is 16. 2 times 16, you will get 32 cm as negative 1. Alright, so that's the answer. Okay, any of you got question? Okay, who answered 0.17 for the period just now? Can I know how you get 0.17? Did you divide 0.17? Okay. How do you get 0.17, Eugene? 3 divided by 0.5. You divide the amplitude with the period, right? If 3 divided by 0.5, I think you got 6. How you get 0.17? Okay, Eugene, but can you understand now how teacher get period 0.5? You understand now how do I get period 0.5? 0.5 you divide by 3. Means you divide with the amplitude. Okay. So now you don't understand. Actually, period, you have to take 2 semicircle here. Do not divide with anything. Okay. For the period, you can just straight away get from the graph. Okay. Only the frequency that you use the formula to get. Okay. 1 divided by t, the period. Okay. Is it clear now, Eugene?
Teacher, can you explain wavelength?
Okay. Wavelength. Okay. Wavelength, we have to use the displacement against time, against distance graph, right? So you use the displacement against distance graph. So if you want to find one wavelength, so one wavelength, I already told you whether it's 2 semicircle, it means it's from here to here. So from here to here, you can see you can form 2 semicircle here, or you can you can take from crest to crest. Okay, here this is also called as the wavelength, or you can take from here to here, okay, throw to throw. So this one is also called as the wavelength. So let's say if you take this one, right? So this one should be 4. Okay, so 4, this one should be 20. So 20 minus 4 also, okay, so this one is 4, this one is 20. So if you want to find the lambda, 20 minus 4, right? So you still got 16. But if you use the throw, also same. For this one is 12, okay, and this one is 28. So if you minus 28 minus 12 also, if you take from throw to throw here, so this one is 12, this one is 28, right? So 28 minus 12 also you got 16. So there are 3 ways to find the wavelength from the graph. The first one, if you use a 2 semicircle, okay, you just scan straight away. So this one is 16, you got the answer. Or you can say from crest to crest, that is 20 minus 4. But this one is quite hard because you need to find the scale, okay, in the middle here. What is the value here and what is the value here? Then you have to minus. So you will get 16. Or you can use throw to throw. Okay, so this one is 28, this one is 12. So if you want to find the wavelength, 28 minus 12. So you will get 16 also. So are you clear?
Yes, teacher. Thank
Okay.
you.
Alright, welcome. Alright, so we move to the next question. So this one you need to calculate the frequency. Okay, so let's see your answer. 1 over t, 0.25, 0.25, 2.5. Why you divide by 0.4? This is 4, right? How come it can be 0.4 here? Um, hmm, hmm. 1 over 2. 1 over, okay. Please don't leave your answer in fraction. No answer in fraction. 4 divide by 2. Okay, good. 5 divide by 4. Why 5 divide by 4? Incorrect. Find hertz. Incorrect formula. Yes, the frequency formula is 1 over t. Not 5 means the amplitude, right? No, F is 1 over t. Yeah, find hertz. Okay. So let's check the answer here. Okay, so the formula for frequency is actually 1 over t. Right? 1 over t. So the period here, so I already told you, right? For period, you have to find 2 semicircle. So 2 semicircle is from here to here. Okay, so means 4 second. Okay, so it's just same. The basically concept is the same. Just the use between what is the graph that you use. So if you the graph is s over distance, so mean you know 2 semicircle is wavelength. But if the s over t means 2 semicircle is period. But as the concept is same, but it depend on the x-axis. What is the unit? And from that you know what is the value that you will get. What is the info that you will get. Okay, so this one is 1 over 4 should be 0.25 hertz. Okay, so are you clear, Eugene? Okay, this is the formula. Okay, the usually the amplitude is only this is, I don't know why how you get 5 actually. Okay, but this is the formula 1 over t. Okay, don't replace it with anything else. So 1 over t, so 0.25. Okay, okay, it's okay. So at least we know, right? Okay, the next one. Oh,
This
sorry,
one cannot
sorry,
go
sorry,
back
sorry,
to the
sorry. 0.5. Okay. So basically, okay, I check the answer first. 1 times 5 over 2. 5 over 2. 5 over 2. Why you got 5 over 2? Wow, someone is become Japanese here. Sorry, I didn't understand. What does he say here? Ah, never mind. I can check. Turkey? What did you say here? Who is Turkey? Yobuseyo. This is Korean, I know. Yobuseyo means what?
Like
Teacher,
hello,
teacher,
are you there?
Annyeonghaseyo. I thought
Teacher,
annyeonghaseyo. This one is
Annyeonghaseyo
yobu.
is hello or
Annyeonghaseyo,
goodbye or whatever. Yobuseyo is
teacher,
like
we found out the rabbit.
Yobuseyo is like informal.
Oh,
informal
annyeonghaseyo.
way of
So,
greeting.
so yobuseyo means the it's not formal. It's a formal one.
Formal one is annyeonghaseyo. Informal
Oh,
is yobuseyo.
okay.
So like example, like me and Krisha talking on the phone, and then I call Krisha, and then I'll be like yobuseyo. That means like, is anyone there or hello?
Oh, hello. It's like
You said
hello.
lagu solo?
Alligator and again triceratops. I don't know, maybe
Teacher, we
the
found the
dinosaur
turkey.
the dinosaur doesn't know how to use a mouse, right? Because it's a primitive animal. So maybe it doesn't know how to use a mouse. Okay, triceratops and also alligator. Alligator. Who is alligator? Where's your response, alligator? Oh, teacher, I want to see my animal. I don't know which one is your animal. What's your answer? Which one? The one that put the. You are Turkey, the one that I keep calling just now. Okay, you are Turkey. Okay. Alright, so next time we change lah. Okay. I don't like this. Wait for me. I bring the spices and roast you for my birthday dinner. For later at Christmas maybe we can find a Venus, right? Because usually Christmas they roast
You still
turkey.
hutang the mikori for us.
Yeah, right. I'm still waiting until now. And you know, I already tried because you said just now my curry is tastes very nice, right? So it's actually nice. I tried the Milo one. Okay, so let's see the answer. Okay. Did I change the slide? Yes. Okay. Sorry, I changed the slide, is it? Okay, so let's try to answer this one. Oh. So the amplitude, what is the amplitude here? So the amplitude is 0.5. Okay. 0.5 cm. Okay, and for the periods, we have to take the displacement time graph. Okay, so displacement time graph is this one. So the period to semicircle means from here to here. Okay, to semicircle, so here is 0.4 second. Okay, and then the frequency is 1 over t. So means 1 divided by 0.4 is 2.5, right? 2.5 hertz. Okay, and then for the wavelength, you have to take this one, okay, the displacement and also the distance. Okay, so again 2 semicircle, 2 cm. Okay, so the answer is 2 cm. Okay, so are you clear for this one? Any question you want to ask teacher? No?
No, teacher.
Okay. So let's move on to the next one. Okay, so this one you have to compare the frequency and also the wavelength and also state the relationship between the frequency and the wavelength, okay, at the constant speed. And then you have to draw a graph. Okay, so let me tell you for the frequency, if the graph, okay, closer to each other, okay, it's very closer to each other means the frequency is very high. Teacher, the space is too small to write. Really? Maybe you can use a symbol. Right, this one, this, oh, sorry. This one. Less than, bigger than, like that. If the space is too small. But in exam, I prefer for you to answer in the full sentence. Okay, but for this one, it's okay. Hmm. Mm-hmm. Wavelength of A is shorter compared to B. A has higher frequency. The wavelength diagram A 1.5, whereas diagram B 4. Say, okay. Wait for a moment. For those who type like this, diagram A 1.5, whereas diagram B 4 cm. Okay, you don't need to describe, alright, what is A, what is B. So you just put there, okay, which one is higher, A or B. That's all. Don't need to put the value of A or value of B. Okay. Where is it? I'm sorry if I call you by your sweet name. Okay, chameleon. Chameleon. Okay, so please write in the yeah, like that. No need to put diagram A what, diagram B what. Okay, so just put A is smaller than B. Okay, that's all. Or A is lower than B. The frequency is higher than B. Okay, very good. Diagram 6A has a higher frequency. Very good. Okay, the wavelength A is shorter. The frequency, okay. Alright, is wider. Okay, wider. Don't forget to answer for A part, okay. Snake, crab, hummingbird, alligator, triceratops, and again iguana. Hmm. Frequency times wavelength. What is the relationship? So when you mention about the relationship, should be higher, higher, or lower, lower, or not change. Okay. Also can. Or you can put inversely proportional also acceptable, but remember that one for the graph only can the answer that only can be accept is inversely proportional, directly proportional, or increasing linearly. Okay, don't put the higher the x, the higher the y, cannot. Okay, that one is only for hypothesis, for experiment.
So, teacher, for this question, we need to write like higher, lower, better.
Yeah, the higher the lower.
Okay, teacher.
Mm. Okay, so I'm waiting for you to draw the graph. Okay, here. The frequency is inversely proportional to wavelength. I don't know. Okay. Okay. So for those who didn't answer the wave one, sorry, the graph, you have to go a graph here. I mean, you don't know, is it? Okay. Alright, so I can see some already answer. Okay, never mind. Okay, so let's try to answer this one. Okay, it says here, it asks you to compare the frequency. Okay, then I already explained, okay, the closer the graph, okay, to each other, okay, so mean the frequency is very high. Okay, so here should be, okay, the frequency of A is higher. Okay, and after that you have to compare the wavelength, okay, between diagram A and diagram B. So you can see the wavelength here is higher, okay, compared to the frequency, okay, compared to the B. Okay, so this one you have to say wavelength of B is higher. Alright, and then the relationship of the frequency and the wavelength. So you can see here, when the frequency is higher, okay, when the frequency is higher, what will happen to the wavelength? The wavelength become shorter, right? So should be, okay, the higher the frequency, okay, the lower the wavelength. Alright, so
Teacher,
that, yes,
can we use longer the wavelength and shorter the wavelength?
okay, sure, can. Alright, and then for the graph, okay, so for the graph, we already learned, right, V is equals to F lambda, okay, so means here is V divided by F, V divided by F is equals to lambda. So mean if I increase the frequency here, what will happen to the lambda here? The lambda will be decreased. So this is called as the inversely proportional. proportional, right? The relationship is inversely proportional. When you increase f, the lambda is decreased. Okay, if you said directly proportional, if you increase f, then the lambda also increase. So that is the directly proportional. But for this one, when you increase the f, the lambda is decreased. So this is inversely proportional. So when you draw the graph f against lambda, the graph should be inversely proportional like this. Alright, it should be inversely proportional like this. But okay, if you change the lambda here, the x-axis here to 1 over lambda. So if you change the graph to 1 over lambda, it will become directly proportional. Okay, so that's the answer for this one. Okay, so are you clear? Any question you want to ask?
No, teacher.
Okay. So we move on to the next one. Okay, so here is you need to know what is the relationship between the speed, wavelength and frequency. Okay, so it says here based on diagram 7A and 7B, okay, you have to name the distance between two successive crests. So for A, okay, so this one is the wavelength, right? Okay, for 7A, this is the wavelength, crest to crest. Okay, and then for B, okay, it says here the time taken for the to travel between two successive crests, we call it as a period. Okay, so here is the period. Okay, and then it says here given the equations, right, the speed is equals to distance divided by time. Okay, and the period is 1 over s. Okay, so you need to and then you can derive, okay, the equation. So you will get v is equals to f lambda. Alright, sorry. So this is the formula that you need to use. For this one, you only can be used in wave equation. Okay, lambda same value as wavelength. Yes, actually lambda is the wavelength. It's the same thing. Okay, lambda is the same thing as wavelength. Okay. Alright, so the next one. Okay, so this one, let's say if you have the ripple tank. Okay, this is the ripple tank, and then you switch on the motor to start the vibration with low frequency. Right, so you start with the low frequency, and then you increase the frequency by increasing the voltage of the power supply. So you need to use a power supply, okay, to use the ripple tank. So let's say if you have a chance to go back to school, so we can do this experiment. Okay, and then you observe the wave pattern on the white paper. So you put the white paper below of it, so you can observe, right, the shape of the wave produced here, right? And by using the stroboscope, so what is the function of the stroboscope here? Because you know wave keep moving, okay, and you move faster, okay. So you use a stroboscope to freeze, okay, to freeze the wavelength, okay. So to freeze the wavelength. Okay, to freeze wavelength. So you can see clearly, okay, what is the shape of the wavelength. And another thing, you can measure the wavelength using your ruler. Okay, so here, when you produce the wavelength, okay, and you freeze the water wave, okay, and the top of at the below of it, okay, you can see there's a line here, so means this water wave produced. Then you can measure the wavelength here by using a ruler. Okay, and then after that, okay, you have to draw a pattern, okay, for low frequency and the high frequency for the motor. So you see here, when the low frequency, okay, the wavelength is much wider. Okay, the gap is much bigger if you compare to the high frequency, right? So what I want you to do now, okay, you have to describe what will happen to the lambda, what will happen to the frequency, and what will happen to the V, okay, when you increase the frequency. Okay, so this is the shape of the wavelength that you get, okay, when it is low frequency and when it's a high frequency. decrease, the wavelength decrease, the frequency increase. Okay, so we discussed. Okay, so I see some of you are, maybe you are not sure. Okay, what's the answer? Okay, so let's see here. So it says here the lambda. So here let's say maybe the red one is the crest. So let's say we assume the red one is the crest. So this one is 1 lambda, right? Crest to crest is 1 lambda. Okay, so this is the lambda. Okay, and for this one, the lambda is from here to here. Okay. Okay. So you can hear here the lambda is decreased. Okay. So the lambda is decreased. Okay, how about the frequency? The frequency, this is low and high frequency. So from low to high frequency means the frequency is increased. Okay, the frequency is increased. So here F is equals to V over lambda. Okay, so when you increase the frequency, okay, so what will happen to the V? The V also will be increased. Okay, so that's the answer. Okay, so let's move on to the next one. Okay, number 1, number 2, and number 3. Then after that, we stop. Okay, this one you have to find the frequency and it give you the wavelength and also the speed. So it should be V is equals to F lambda, right? Why only 7 respond? So others? Teacher, my screen is blank. Is it? Any other people face the same problem? Your screen is blank. Maybe you can try to log in again. Okay, log out and log in again. 0.773, 0.770, F plus. Wait, check. Others are okay, right? Maybe the line lah. I think the line, the internet one. Yeah, I see. It's white. Like nothing come out. Maybe the line slow. Because here mine I can see. This is yours. Should be like your screen should have like this. Okay. Okay. So I give you 1 more minute, then we discuss one by one. Mm. Three thousand mega ms. Is that your internet speed? $3,000 megabyte, is it? Wow. Mine is only like 100 megabyte. Oh, yeah. 100 MB, I think. You're using what? Unify? Teacher, my internet went off few times, so the link isn't in the chat. Can teacher send again? Yes, sure. Oh, message. Oh, thank you. All I know is my extra slow. I'm using like 100 MB, I think. Message also. Mine is also message. Okay, so can we discuss? Right? So let's discuss the answer for number 1. So it says here the frequency. Ping latency is technically more correct term. Means the time is taken for small data. Oh. You don't ask me lah about the IT part. I'm not that good. Using maybe I can, but you know that all the terms okay in IT I'm not that good. All I know when they say 100 megabyte, 300 means 300 is very fast like that. You Google Control C, Control V. Okay, so let's answer this one. So it said they ask you to find the frequency. Okay. So the frequency and they give you the wavelength. Okay, so the lambda is 4 cm and the velocity is 1.6. So V is equals to F lambda. V is 4. F you need to find the lambda is the lambda this is 1.6. This is 4. Right? So you should get the F is 0.4 hertz. Okay, so 1.6 divided by 4, so you get 0.4 hertz. Okay, for number 2, it said before a concert start, the musician tunes his guitar string to note A, right? And which has a frequency of 440 hertz. So the F is 440. Okay, what is the wavelength? So we need to find the wavelength. Okay, and then another one is the velocity. V is 340 already given. So V is equals to F lambda. V is 340. F is 440. And you need to find the lambda. So some of you got 0.077 meter. So that is the wavelength, right? So what is that is the wavelength. Okay, for number 3, okay, this one you need to find the amplitude. So you already know the amplitude is 10 cm. Okay, and then this one is a displacement again time. So of course you can find the period by find the 2 semicircle here. The length of the 2 semicircle that is 0.4 second. And then the frequency we use 1 over T. So 1 divided by 0.4 you will get 2.5, is it? Yeah.
Yes, teacher.
2.5 hertz. Okay. How Mafia or Google works? That's how Mafia Google works. Okay. Oh, you Google. I thought you already know. Okay. So I stop until here. So after this, we move to the next subtopic. Okay. So I think you already understand for this one. Okay. So for the objective part, later we will do the objective part. Then we go to the next subtopic. Okay. So I see you on Saturday. Okay. So take care class. So bye. Have a nice day.
Thank you, teacher.
Thank you, teacher.
Thank
Bye,
you.
teacher.
Take care. Stay
Thank you, teacher.
safe, everyone.
Bye, teacher.
Bye
Thank you, teacher.
bye.